Okay, so let's fill out the blank spaces for your vocab. The restrictions that we state from the denominator can be one of these two cases or both. Okay, example 2, we had both the hold and the vertical asymptote. First is what we call a hole. Now, a hole is oftentimes called removable, so make sure we know we can use either words, okay, removable discontinuity or a hole, and you should know it's the same thing. If the factor x minus a can be removed or canceled or reduced, or we got rid of them after we simplify, then x equals a is a hole in the graph, meaning that we had to take that a value, plug it in to get the y value. Now, a vertical asymptote is when your factor x minus a is still in the denominator after we've already simplified everything. Since it was not removed, then x equals a is now a vertical asymptote of that graph, okay? We also talked a little bit about the horizontal asymptote. Now, for our class in Algebra 2, the horizontal asymptote will never touch your graphs, okay? Your pieces, the 2 pieces. Now, in next year, in higher math, pre-calculus, it will sometimes can cross over your horizontal asymptote. So the horizontal asymptote is what the graph will get closer to, but will not touch in our class this year. Okay, that's not the case for next year, but what our function is going to get closer and closer to as we go. X goes to the right very, very far, like 100, 1,000, infinity, what we call it, or x goes very, very left, like a negative 100, negative 1,000, or we call it negative infinity, okay? There are some cases here, so let's pay attention to how we get the horizontal asymptote, okay? First, if the degree of the top is exactly the same as the degree of the bottom, that means they are the same, then your horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator, the top, and b is the leading coefficient of the bottom, okay? Excuse me, guys. If degree of the numerator, which is the top, is less than, this is called less than, the degree of the bottom, then your horizontal asymptote, students, it's just simply y equals to 0. Degree of numerator less than degree of the denominator, y equals 0. The third case is if the degree on the numerator is bigger than the degree of the top, then we don't have any HA, okay? I use HA to short for horizontal asymptote. Let's go try some examples. Looks like we have A, B, C, D, 4 of them, and then you have to give me one question on your own, okay? All right, find all holes and asymptotes. Let's give it a look. I need to make it fatter really quickly. All right, example A. f of x equals x squared minus 4x plus 3 divided by 2x squared minus x minus 15. So first step, guys, is factor out everything. So what I would like for you to do is take a moment to factor out the numerator and the denominator. Voila! Hopefully you guys have these as your factors. Now remember, we have to understand our restriction, right? Our restriction is taking 2x plus 5 equals to 0, x minus 3 equals to 0. So currently, we should have 2. X should never be 3, and x should never be negative 5 over 2. But what do these do? Are they holes? Are they asymptotes? And what kind? So first, we could reduce these, okay? So that means this right here, x minus 3 is going to be your hole, okay? So your hole is at x equals to 3, hole. Then we have to plug it in. Since we reduce it, x minus 1 over 2x plus 5 is what we have left, okay? So what we have left after we simplify is this. Then we take our x value, whole, x at 3, plug it in to get your y value. So y equals 3 minus 1 over 2 times 3 plus 5. That's going to be 2 over 6 plus 5, so that's going to be 11. So your whole is now going to be at 3, 2 over 11. So that's going to be your whole. So we have one whole. then because this denominator stays, and we said it can't be, so how we write our vertical asymptote, students? Vertical asymptote is what's left after we simplify in the denominator. Instead of writing what x cannot be, it is a line, so we write what x is at, 5/2. So that's your vertical asymptote. Now then we look at our degree on the top, and it doesn't matter if you look at the original or you look at the reduced. They're the same for your HA, okay, horizontal asymptote. Asymptote. All right, and if you see me shorting it HA, that's what it is. And if you see me shorting VA, that's what VA is. Horizontal asymptote, remember you have 3 cases, right? We have to look for the degree on the top and then to see what's happening. The degree on the top is 2. The degree on the bottom is 2. The degree means the exponent of the highest exponent. If you look at the reduced form, the degree on the top is 1. The degree on the bottom is also 1. So right now, degree on the top, degree on numerator equals degree on denominator, okay? Then we are going to look for what case? Okay, 1, 2, or 3. Winner, this one, okay? So your horizontal asymptote is the leading coefficient of top divided by the leading coefficient of the bottom. And again, it doesn't matter if you take the reduced or non-reduced, because the reduced or non-reduced, the leading coefficient is the same. There's a 1 right here, and here's a 1 right there. They both have a leading coefficient of 1. So horizontal asymptote is always y equals, I want you to say it. Horizontal asymptote is always y equals the degree on the top divided by the degree on the leading coefficient of the top, which is 2, which is 1, divided by the leading coefficient on the bottom, which is 2. And we are done. That is the horizontal asymptote. This, guys, it's only when the degree equals to each other, okay? Let's do B. B, similarly, first thing is we are going to factor everything out. So take a minute to factor out that bottom. Okay, hopefully you have this. Now, as you can see, we can't cancel any of our denominators, right? Because look at our restrictions. X can't be, excuse me, -5, and X can't be 2. And neither of these factors are reducible. Since it's not reducible, both of those will be vertical asymptotes. And so take each and set it equal to 0. Vertical asymptote, guys, is going to be at -5, and vertical asymptote is going to be at +2. So this is the same process of how you guys solve a restriction, except that these are lines, so we have to say that what they are equal. All right, so let's look for HA, horizontal asymptote. Horizontal asymptote is all about the degree on top, okay? Degree on numerator. I'm going to say blank degree on denominator, and then we're going to figure out if it's bigger, smaller, or equal. So on the numerator, the degree on the bottom is 2, okay? Degree on the top, I have no x here, no x, okay? That means is usually, if you have no x, and the reason we have no x is technically you can view it at x to the 0 power, because any number to the 0 power, guys, is always 1. So no x means the degree is 0. So the degree on the numerator is 0. Degree on the denominator is 2. Well, clearly that means it's less than. So right now, since it's less than, we go check out our cases. Let's roll up. Whoa, case number 2. Yes, it is. The degree on the top is less than. That means the horizontal asymptote is always going to be y equal to 0. Y equal to 0 is our HA.